is off, so. Okay. So this is read. When you go to YouTube, look for that NHS Physics Quiz 3 review. Type that into the search engine. And over there, so the first thing we're supposed to do is look at the procedure question. Alex, can you turn that to 0 up there because they're going to come on here in a second. Just that knob. Can you shut the door back there to the back room? Thanks. Okay, because they're about to come on and talk to us. First thing it says in the review is there'll be a procedure question over what happened in the lab. And just to remind you, in case I show this years from now, this is the lab that we did. Okay, and this is a static. It's static, right? Ooh, what we learned in first through third hour. We've already learned some of this. What would I call? Say I have these two force vectors, right? Yeah. And they're at a certain direction and they're a certain length. What would I call this hanging vector? The equilibrant of these two, because that ring is not moving. Now, if that's a profile view, if we go out on the West Lawn on Monday and get a big ring, a big steel ring, a big horse collar or something, and then we hook big hooks to it, and then we get big ropes, and we all pull, we could have an equilibrant. So that's what you show. That's the difference of equilibrant. If I take it away, now the ring is still stationary. Now this is the equilibrant of that. Okay? You could say, equilibrant-wise, and those in 6th hour, we'll talk about this today, you could say that this is the equilibrant of these two. It doesn't matter. But the thing is, the ring's not accelerating, therefore, equilibrant. So anyway, the question from the quiz, or from the lab, will be some kind of procedure thing. I'm just checking, did you actually do it? Do you know what I'm talking about when I talk about the lab? I don't know. Multiple choice question, I really don't know what it's going to be yet. Okay, so that's the first question. So the warning is, if you didn't do anything with the lab, if you're gone that day, you need to come in and just talk about it. Talk to me about it or somebody else. Next question says there'll be a vector construction head-to-tail method. Let's try one of those. I'll do it the best I can with this. Two ways to construct these vectors, combos, is by head to tail or by the IJ format, which we're doing now. But this is vector addition, head to tail. So here's the way, let's make up a question. Let's make up a question here. Let's say that, all right, let's say that we have 3 vectors. We got a green one. Oh, no. Okay. Let's just write it out. It'll be something like this. 3A plus 1/2 B minus 2/3 C. Okay? And then we have our vectors. You got A, and I know you're sketching. You'll have a graph. I don't have time to put a graph up here. You'll have A, you'll have B. B looks like that. Okay. And you'll have C. C, let's say, looks like it's 2/3 C. Okay. You're supposed to add those up. Okay. So we gotta triple the length of A, and then it's just head and tail. So 3A will be, I'm being approximate here, about like that. See, there's my calibration problem. This is embarrassing. 3A. Okay. 3A looks something like that. And then a 1/2 B. So I'm going to add the 1/2 B to that. So I cut that, I should have made it, because I think how tiny it is already. Well, okay, so I cut it in half, and now it's parallel. I'm being lazy. You know, you can take your ruler and got a nice line and make a parallel with your ruler. Half B. Okay. And then I'm going, that's head to tail. And then I'm going to take 2/3 of C. I gotta take a minus C. So I'm gonna flip my C around, take 2/3 of it, which once again I'm you don't be as approximate as I'm being. You're gonna use a ruler. So interest of time here. So that's 2/3 C. And where's my resultant? Okay, I'll make that in lime green here from the very first tail to the last head. So with a ruler now, as I should have been using it the whole time. The ruler. This calibration. Okay. Where do I put my arrow? Crucial part. My lime green is my resultant, but where does my arrow go? At that end, not that end. And I know I'll see students do it. They'll do it at that end because they want to keep that head to tail process going. But no, it's very beginning to very end. So there's my arrow. Got to show the arrow. Okay? So that's how to do a head to tail method. It'll be something like that. And it'll have a grid system for you. All right, next page. The next thing says a scalar versus a vector. Now what's a scalar? Give me an example of a scalar. All right, I don't know if that's going to show up very good. Speed is a scalar because it has no direction. So speed, anybody else got an idea? Temp. What about area of a square? What'd you say? Time. Area. Volume. Anything else? What about force? When I use force, don't I, boom, I'm going to hit in a direction. So force has a direction. So down here with vectors, we're going to put force. What else has a direction? And a length. Velocity. What else? Displacement. Now that's my delta x, my delta y. What about what's the scalar?
Distance.
Okay, so a scalar the distance up here. Anything else? Anyway, you get the idea. So I'll ask you maybe a true false question, or which of the following, or I'll list a bunch of things and I'll say, okay, now, which one's a scalar, vector, scalar? Those kind of things. All right, so that's that question. Then we got to go, now we're doing all from 3.3. So the majority of the quiz is 3.3. We'll have a stack and rack column, and in that one, that will be easy, because let me give you an example. I'll have like 3 vectors. Always do the I first. Okay, 3I. Plus 4J, and we'll make this velocities, meters per second. P is 6I minus 2J meters per second. C is negative 8I plus 3J newtons. Now, can I do this? A